Why did you want to be an astronaut?
Yeah, it started all for me with my grandmother coming home with 3 science fiction booklets, and she bought it for 1 guilder, which is what maybe $1 or so by now. And these science fiction booklets were numbers 10, 11 and 12 in a series, but that was the trigger for me, because I got into this world of astronauts and spaceships and alien life forms, and that was in the time that I also saw the cars on the moon and the Apollo flights.
I was going to ask, how old were you and what were the books about?
Yeah, I think I was about 11, 12 when the spark when the spark happened. These were novels, and it's still going on. It's a science fiction, originally German, I think. It was translated in Dutch. They have been in America as well. And it's called Perry Rhodan, and it's a science fiction series about the Earth, actually, about the future history of the planet and all the contacts with alien civilizations and things like that. And together with popular science magazines, in which you could see a complete technical drawing of Skylab, the pictures of the moon landings and the movies. Then that was the time that I dreamt about it, because it was adventurous, it was exciting. Then the space shuttle came. And that was already in another era. I was studying medicine, and then I saw how beautiful it was. I saw this footage of floating astronauts and through the view on the Earth through the window, IMAX movies. And then I thought, oh, this is also beautiful. So it was exciting and adventurous, and then it was so intriguing and beautiful. And then the third thing came, because during my medical studies, I started to be more interested in the science part of it and what happens with humans in weightlessness. So, and then I felt also, hey, this is useful. So this was the combination of adventure, beauty, and usefulness. That made me decide, okay, I want to go this direction, and if I can, I like to go there myself and experience this view on the planet and the weightlessness. So that's how it all started.
They set the scene for where all this was happening. Tell me about your hometown. Tell us what it was like for you to grow up there.
Yeah, I'm born and raised in Amsterdam, capital of the Netherlands, and I like it. It's a very international city. Actually, it's the most international city on the planet, even more than New York, I understand. So if you look at residents from different countries, so it's a lot of international people there, and it's a very lively city, a very old city. And I really had a great time. I mean, I spent my youth there, and all my friends are there, family. That's absolutely my hometown. And every time I'm not much at home. I'm not much in Holland. And every time I come and I fly in and I see my country from the air, it gives a good feeling. I feel like I'm a world citizen. I mean, I'm everywhere. But seeing your own country and the green meadows and there's a lot of water, all the rivers and the lakes there, it gives me absolutely a feeling of home. So wherever I go, I always have a feeling that I have my home base in the Netherlands, and my favorite town is then Amsterdam. And I like it to go through Amsterdam, to bike. With the car, it's a disaster, like a lot of cities. But to go through Amsterdam and see all the old houses, there's so much history. I imagine, these were the houses where the people lived during our golden century, in the 17th century, when Dutch ships were all over the planet trading. and discovering new things, and that is something I compare it a lot with. So the exploration of those days, I see space flight as the next step of exploration, and it's yeah, I feel that also in my town. That Amsterdam is built. Say on this tradition of exploration and trade in strange areas with different countries.
What's it look like from space?
Yeah, Amsterdam has a nice feature, and that's because we have all these canals in a semicircle. So this is something you can see, and there's one big advantage of Holland. It's so small that you can see it in one view and take it in one picture, and it's a very densely populated area, but nice and small. And from space, you can recognize a lot, because like with flying, the edge between water and land is very, very clear, very visible, and also from space you can see this very clearly. I mean, I recognize a lot of small details when I see it from space. You have to be fast though, because if you're a little bit too late, you already see Denmark and, and beyond. So, yeah, it's a pleasure to see your own country, but you know, the whole planet is so beautiful. There's so many spots that you want to see, and like I said, I feel like a citizen of the world. So, you know, I have a home in Star City for years already. I have a home here in Houston for so many times. I go to Montreal, we go to Japan, and of course the European Astronaut Center in Cologne. So there's all these places, Munich, where we have our flight control center, and all these areas are part of the space dream that I'm living. It's different than I thought, because I thought always I would fly on the space shuttle, because, you know, Russian space flight, it was behind the Iron Curtain anyway. So, and things totally changed. I would never have imagined that me being a medical doctor would fly as a board engineer, as a co-pilot on a Russian spacecraft. That would be that was very strange. So things develop in a different way than you think.
I'm going to get you to tell us how they developed for you. You grew up in Amsterdam. Pick up the story there through your education and your professional career that led you to becoming an astronaut.
Yeah. So the dream started as a kid, but then I thought, okay, space flight, something for American test pilots, and they do something in the Soviet Union as well. So that was not very realistic. Until end of the 70s, when the shuttle was being prepared and the space lab, ESA was building the space lab, and then all of a sudden there were European astronauts and a Dutch one, and he was a scientist, Wilbur Ockels, anyway, and he was wearing glasses in the picture. I had contacts, and I thought, well, you can never become an astronaut if you have glasses. But then all of a sudden I saw him as a normal person. And then I saw John Young in the cockpit of the first space shuttle with glasses on. I thought, hey, wait a minute, these are normal people. And then I started to think, okay, this is interesting. I started to work on it. So, okay, what is required? What do astronauts? What kind of background do they have? In the meantime, I started to study medicine in Amsterdam, and during that study, I got into contact with a professor, Professor Oosterveld, and he was a specialist on on the vestibular organ, ear, nose, throat, ENT specialist, and he worked for a while for NASA. On some of the Apollo flights as well, and I read an article in the newspaper, so I approached him, and then I could work in his lab, and this is how the whole thing started a bit, building up my career, because through him I could get into the Dutch Air Force, and I did research on spatial disorientation in fighter pilots. It was very interesting, and you know, before you know it, you're the expert, and they would like to keep you there, but I thought, okay, Dutch Air Force, great stuff, backseat flights in the jets, but they don't do anything with space flight. So then I changed and I started to work for the aerospace medical institute that we had in Soesterberg in Holland, where I trained monitored centrifuge runs for the NATO pilots, for example. I did research in the centrifuge and hyperbaric chamber, flight physicals for pilot, lecturing, and I got into contact with the Institute of TNO, Institute for Applied Physics, and they started with. Then I really got into the space business because they started with parabolic flights and doing research on all kind of different topics, space motion sickness, vestibular organ. So then I experienced the first weightlessness as well. That was very interesting, the parabolic flights. And then I was constantly investigating, okay, how can I work for a space agency? Because that was the ultimate dream. The astronaut thing was okay. That was very difficult to get in. We had 3 astronauts, and the new selections were still, in the future somewhere. But there was several life science congresses where I went to, and then I started to talk with people from ESA. Okay, how can I work in this field? And I said, well, we always work with national agencies, with agencies and national institutes. But then I got a telegram. Actually, it was sent to the Air Force, the telegram, but I already left the Air Force. So a friend from the Air Force came to me and said, yeah, we got this telegram for you. And I was in the meantime working in the Civil Institute, and I looked at it. Do you want to come for your application? I thought, I didn't apply for anything. Yeah, and the date was the next day, so totally blank. I went to ESTEC, the ESA Technological Center in Noordwijk in the Netherlands, and so I came in there. I thought I have a good job, so nothing can happen to me anyway. And then I saw some familiar face that I met on the life sciences congresses, and the last one was in Italy. And then the people apparently noted down my name, and I looked for an assistant project scientist. And since I showed interest, they approached me, and I didn't know what it was about. But then I said, you can work on the shuttle mission, on the Space Lab mission. We need somebody to support us for the life science experiments. And that was a great opportunity. It was only for a year. I had to give up the other job, so it was a risk. But if you don't take risks, you never get anywhere. So I thought, okay, I do this because this is what I want. I want to work in the space environment and coordinate experiments for a space shuttle flight. This is great. And it was SDS-55. So that was a great experience, and it was supposed to be a year, then the flight was postponed. In the end, it was 2.5 years as a research fellow. And then I became a contractor after that for ESA. So they couldn't get rid of me anymore because it was too nice to work there. It is a choice you make. I'm a medical doctor. I like the clinical work. I liked also, so you have to decide, okay, which way am I going? And I thought the space flight is too tempting, and I want to work in this field. And then we also got the situation that ESA wanted to have more astronauts. And then I thought, okay, this is my chance. So I was in the meantime working for ESA, and then the astronaut selection came, and that was the beginning of the 90s. There was actually the first application letter ever that I wrote was to become an astronaut. And so there was an interesting challenge. Okay, how do I write an application letter, especially? But to my surprise, I got more and more invited for the first round and the second round. And if you are getting in this selection process, you think, okay, I tried it, and that's good because otherwise you regret it. If you don't try it, you regret it. But I didn't expect to get on and on because the people around you are so good. You know, you have these people who have different degrees, and they're also pilots, and they're nice as well. And you think, okay, I don't have a chance. So every time it's a surprise that you're still in, And and then the final. We had 5 candidates from the Netherlands. Every country was supposed to put in 3 or 5 candidates. And then in the end, ESA's plan was a bit reduced because they had big plans with the Hermes space plane and the Free Flyer and part of the Freedom space station. That changed a bit, so the team was reduced, and I didn't make it. I was in the last group and I didn't make it. But then they said, well, hang on, because you never know what happens. And indeed, several years later, I kept on working for ESA, and several years later, they unified the teams, because we had a strange situation in Europe that we had an ESA team and we had a French team and a German team and even some Italians, and so it was some kind of competition between French astronauts that worked for CNES and British astronauts that worked for ESA. So they unified the teams, but then for the small countries who don't have their own teams, there was, of course, was not so good. So they said, okay, we also take some people from the finalists of the last round, and that's how Frank de Winne and me came in. And and that's the road that I took. It was a long road. There could have been a lot of distractions, and I'm glad I hang on. I took the risk of not going into clinical work, which I liked, and luckily it paid off. And still, I mean, I was very lucky that I flew, because Europeans don't fly so much. Once you're selected, it can take a long time before you fly. I mean, people like Claude Nicollier, Christer Vogelsang, they waited more than 10 years, 11, 12, 13 years. But it's all worthwhile to go through this whole ordeal. Maybe that's a heavy word, but it's a long process, and you have to be very motivated and determined. And I think that's one of the most important things, patience and motivation. Hang on.
You mentioned risk. You were talking in that case about the risk of giving up one kind of job to take another. Well, now you have a job that has some physical risks to it that most of the rest of us don't ever have to face. So the question becomes, why do it? What is it that we're getting out of flying people in space that you think makes it worth doing? Yeah,
I think the reason is very fundamental. I think it's the exploration, the urge to explore that people have. Humans went into deserts, into mountainous regions, onto the poles, on the water. I mean, we don't belong there. We are not fish or ducks, but we have our intelligence, and we're curious, and we want to know what's there. Is it better there? Can we get something from there? People have been going to places that are not very favorable, but they got a lot out of it. Because they found fertile grounds, or they found freedom, and trying to escape from a bad life. They found oil or minerals. So that it's part of our nature to explore. And after the deserts and the oceans and underwater and then the air, the space is just the next one. And people will always be curious and go there themselves to look themselves. Now we have, of course, a very good technology now to put our eyes forward and put our hands forward in the form of robots, but the species itself also wants to. Maybe it's even say a biological necessity. I mean, if we spread humankind, it's a better way from a biological point of view to survive, and so. I think it's a natural process, and we don't want to take unnecessary risks. So safety is a very important part of the whole thing, because we want to live, to tell the story and see what we found there. But it's a calculated risk. You know, there's a lot of good people looking at all the aspects. Safety-wise, but also for experiments, there is ethical committees, and there is safety committees, and whatever, to scientific peer groups, so that what you do is tested by a lot of good people on the ground, and okay, it's worthwhile, there's not so much risk, let's try this. It's not the only profession. I mean, that has a risk, of course. I mean, if you are a fireman or you work for the police force or military, you know that there's a risk. And you think about that before. It's not that that you're sitting on a rock and you think, oh, this might be dangerous. You know that, you know the statistics, and you decided a long time before that okay, I'm willing to take this risk, to be part of this, to experience something very special. And also, like I said, the three things that made me do this, the adventure, the beauty, and the usefulness of the whole thing. And that makes it worthwhile for me.
You're getting ready to launch to the International Space Station to be part of Expeditions 30 and 31. Andre, in summary, what are the mission goals for your time in space, and what are you going to be doing this time around?
Yeah, it's different than my first flight, where it was science and piloting or co-piloting the Soyuz. This time I still do the same, but there's a lot more extra tasks. It's like operational tasks. So one of the most interesting things is visiting vehicles that we're responsible for. But I'm also trained to work with the robotic arm, potential EVAs. So more operational tasks as well. It's a long mission, half a year, meaning that now things are important like maintenance and repair. Being really an astronaut who lives on board and takes care of the whole space station, and not only visiting, doing a lot of science and return. We still do a lot of science though.
Well, you mentioned your first trip was a short one compared to this. What are you looking forward to now? Is it all those things you just mentioned?
Absolutely, yeah. The space station is twice as big. We have the Columbus module now for ESA. We have the JAXA module, a lot of extra nodes. We have the cupola. Also on the Russian side there are extensions, so that means that it's more or less a new station for me, twice as big. That's one of the things I look forward to see how it looks now. And during my first flight, which was very, very full, so a lot of hard work, after 11 days I was returning and I thought I want to have more of this. I want to experience. I really want to live in space. That's why I absolutely wanted to go a second time. So I look forward to adapt totally to the space environment, to live there and to enjoy the planet even more than on the first flight.
As a doctor, you studied how people respond to that environment. You had a short experience for it. How did you respond to it?
Well, it was very interesting for me as a medical doctor, and also because I gave lectures on the topic, etc. And then if you experience things yourself, it's very this is what I thought all the time. Now I feel it. Some things are just surprising, that you think, hey, this is it. You know, if you see a flash, for example, from that you know from radiation, that's something interesting because you talk about it and then you see it. This is it. You recognize it. And another thing is fluid shift, for example. That really the fluids in the lower body move up, and you get a full phase as if you have a cold, and you recognize these things. Space motion sickness, very short. I had that. Same thing. That I thought, okay. This is what I always talk about. So that's very interesting to experience these things yourself. Now for a long duration flight, other things are becoming more important, like muscle atrophy, bone loss. These things you don't notice straight away. You can measure them very well, but you don't notice them. So these are things that come up for long duration flights, and from a medical point of view, I'm very interested in those effects and how to counteract them, of course.
You're going to be the 5th European Space Agency astronaut to do a long duration mission on the International Space Station. What's the significance, do you think, of this flight and the continuing presence of European astronauts on board this station as part of this mission?
I think one of the most important things of the space station is international cooperation. I mean, all these nations work together on the biggest technological project there is, in a very nice way, solving all these technical issues between the different countries. And I think it's a nice to show the people on Earth this is how we can do it all together, and do things positively. And Europe is part of this partnership. So we participate, meaning that we have every year more or less an astronaut on board for half a year, and that is of course very important for the people in Europe, for the European industries, and I think it's good that we continue this way and that we are full partners in this program.
You made reference to the fact that the station is a lot different now than it was the first time you were there. It was still being built, and the assembly is almost done now. So describe for us all the modules and the facilities and whatnot that are going to be there for you and your crewmates to live in and take advantage of during your time in space.
Yeah, space station is pretty big by now, and from all the different partners we have parts. From Canada we have this beautiful robotic arm, of course. Then of course we have the American segment and the Russian segment, or the USOS segment, meaning that on that part we also have the European module, Columbus. We have the JAXA modules. And then we have the different nodes, additional nodes. We have now also, when I was there it was only node 1, now we have node 2, with the sleeping cabins, for example. We have node 3, which is the area with the cupola, where we have our training equipment. So this is the part I am, say, partly responsible for as well. And then, of course, the Russian part, where our Russian colleagues work most of the time, and where we have dinners together and things like that. And also important for Europe, where the ATV, the automated transfer vehicle, is docking during my increment, for which I'm then also responsible. So I will be busy in all parts of the space station. That's nice.
I've heard some people say that it's so big that it's almost like they get lost, and I think they're kidding, but are they? Is it really that big, and do you get confused about where you are?
Oh, absolutely. I had that already in my first flight, and then it was only half as big, because you don't have up and down, and you don't feel it with your vestibular, with your equilibrium system. So there was a moment that I floated into a module, and I thought, I've not been here before, and why do they have lights on the floor? Turned out that I came in upside down, but you don't notice it, so everything looks different, and it's nice. In the beginning it's confusing, but in the end you have the space station is 4 times as big, because every time you can make a wall, or the floor, or the other wall, you can make that the floor, and the ceiling, so that you have every time a different view, so in the end you can play with it, with the fact that you don't have up and down.
Let's talk about what you're going to do while you're there. The whole point of the International Space Station is to do a lot of science research. Now you've got 6 crew members, several laboratories, including Columbus. More research is being conducted. And one major area, one concentration, is to find out how people can live in this environment for long periods of time. Give me a sense with some of the experiments that you and your crewmates are going to be doing in this area during your mission.
Yeah, the life science experiments are always very interesting for me personally, but also because they cover a lot of territory. I'm going to follow diet with salt, for example, the solo experiment, to see what the effect is on bone loss. But we also do psychological experiments to check your reaction time. We look at, which I like very much, we look at our organs with ultrasound, for example. We take ultrasound pictures, movies of the heart, of blood vessels, even of the eye bulb. So that's a nice skill to learn, especially for me, and I like these experiments. We have strength measurements. We have experiments to see how your endurance changes in flight. So on a lot of different fields, we have these kind of experiments. We even have experiments to check, say, the metabolism of the body with hairs. So it's a Japanese experiment called hair. We check for flora and fauna on board, and to see how things are developing in that field. So it's a lot of different aspects of life sciences that we cover. So that's interesting.
We hear people talk a lot about the exercise that crew members do as a way to try to maintain their fitness. But the life sciences experiments are more than just the workout that you do.
Yes. You have two different parts. One is what happens with people in a weightless condition, and the other part is how do we keep them healthy so they can come to Earth and walk out of the spacecraft again. So to do that, you need to have your exercise every day. We have different pieces of equipment for that, for cardiovascular to stay in a good condition. But very important is also what I mentioned before, bone loss. And we have great device now, the ARED device, where you are actually weightlifting. We don't have weight, so we do this against vacuum cylinders, but we can create the force that is needed to put the stress on the bones, and that seems to work very well. Before we had the treadmill. We still have the treadmill. We have two actually for your condition, but especially this weightlifting is very promising to try to stop the bone loss that happens in weightless conditions. So every day there's a big block of time dedicated to staying in shape.
In doing all this study about how the human body is impacted in this environment and studying countermeasures, are you coming up with things that are applicable for those of us who are stuck on Earth and suffer from similar problems?
Yeah, well, one of the things, of course, is that astronauts are healthy people, but still they suffer, for example, from bone loss, which is a condition that a lot of people have on Earth. The population is getting older and older, so bone loss is really a serious problem. But there you also have all kind of other hormonal changes and other problems that might mask the situation, and therefore the astronaut group is a nice group to study, because you have say more pure situation to study this and to see what you can do against it.
So we're coming up with things that are helping us on Earth as well as learning about how to go somewhere else.
Yes, absolutely. We have experiments who look at fundamental things, just to know what happens when you don't have the influence of weight. But then you also have applicable experiments that are really that you can say, okay, with this equipment we can also use it. This knowledge that we gain, we use it in hospitals, for example. Or if you have a protein crystallization experiments, that is also on our flight, one of the Japanese experiments, for example, to look at the exact structure of proteins, and then it might help very well to develop medication for something. So we have fundamental experiments and experiments that you can really applicable to situations on Earth.
Well, we've been talking about experiments that have to do with the human body, but as you made reference to, there are lots of other kind of experiments where you're not the subject, but you're the lab assistant, I guess,
yes,
for researchers who are on the ground. Give us a sense of the range of the other kinds of science that's underway on the International Space Station.
Yeah, it's very interesting. During my flight, all the things that I was interested in. Okay, what can you do in weightless conditions? I have them more or less on board. We have the Marconi experiment, where you look at fluids and convection. We have a protein crystallization experiment. We have an experiment with in material science with solidification of materials, and these are things that are not on the human body. It's physics, and some of the things you cannot see because it's inside of the equipment, but other ones you can, like a fluid bridge, building a fluid bridge, for example, and this is very interesting. So in all these different fields, I have experiments of that kind, and we even have experiments in the field of technology, like robotics. So this is also nice.
The European Space Agency has provided one of the laboratories that's on board, specifically to Columbus. What kind of research is going on there?
Yeah, in Columbus we have experiments in the field of fluid physics, biology, material science, human physiology. We got the MIRIS machine there now. So there's there are the HRF racks are also in Columbus. So it's not only European racks there. We have a mix, and a lot of the life sciences research equipment is placed in Columbus. So meaning that when we do an American experiment, for example, with ultrasound, we do it in the Columbus lab, and that's a nice thing. So we mix the equipment, and we mix the people, and we mix the experiments all over the segment.
It is an international space station, after all.
Absolutely, that's also how I feel it. And we fly up in a Russian spacecraft, and we do experiments in a Japanese module. We work with a Canadian robotic arm, and then we have lunch in the American segment, and then we dinner in the Russian segment. It's really an international space station.
Along with the science work that you guys will be doing up there, you're also responsible for keeping the laboratory and the whole building, if you will, functioning. Outside of specifically science work, what other kinds of work do International Space Station crew members have to occupy their time?
Yeah, it's important to keep the station in a good shape. So that means that you have to clean things, you have to do maintenance, and if needed, to repair things. So that means that you spend time on cleaning filters in the ventilation system. Sometimes you have to replace a pump that failed. So you have to get into the racks and replace that. So these are tasks that are important for keeping the system, but also monitoring the environment. We make regular measurements of the water quality, the sound in the space station, the air quality. All these kind of things have to be done to have a working space station, so that we can do the science. So part of the time on board has to be cleaning, maintenance and repair in order to get all the science done that we want.
A lot of work to do when only a few people to handle it.
Absolutely, it's good that we have 6 people now on board, and we are very busy with all kind of activities like the science, the sports, what we talked before, and then the operational tasks, like the visiting vehicles or potential spacewalks. And if there's a visiting vehicle, there's a lot of time spent of course, getting the vehicle docked to the space station, but then we have a lot of cargo. The space station is full with equipment, and we have to be very careful that we remind everybody where it is. So everybody on ground and in space knows where to find a certain piece of equipment or a certain tool. So the loading and unloading of visiting vehicles is very important. So we have this system where everything is taken care of. It's all in databases, where is what, and we have to be very careful that everything we move is registered, so we know where to find it, or the next crew knows where to find it, and that takes a lot of time.
Let's spend a minute or two here talking about visiting vehicles. These days, the International Space Station is getting supplies on ships that are launched by Europe and by Russia and by Japan. And there are 2 new cargo ships being developed under NASA's Commercial Orbital Transportation Services program that are now scheduled to have their initial flights coming up while you're on board the station. Fill us in on these 2 new vehicles. Tell me how they mix in with these current ships in order to keep the station supplied.
Yeah, that's very interesting what we're going to see during the flight. We have the Dragon from SpaceX in California, and the Cygnus from Orbital, and that indeed is a new thing from commercial companies. I look forward to that very much. They will, like the HTV, like the Japanese cargo vehicle, they will come up to the station and have to be grappled with the robotic arm. and then dock to the station. And I think it's very important to have all this diversity of ships that can bring up cargo supplies to the space station. The Dragon has an interesting capacity, and that is that it has a heat shield, so we can bring things back. And that's very important, of course, because the only vehicle at the moment that can bring things back to the Earth is the Soyuz, and that's pretty cramped. So it's very limited what you can bring back for science. So that would be a great capacity to have additionally from the Dragon.
How do they compare with the other vehicles, say in terms of size or pressurized or unpressurized cargoes?
Yeah, they're a bit smaller than the ATV from Europe and the HTV from Japan, but you can enter them. Some of them have also can have payloads outside, but it's a unmanned vehicle that we grapple, and then when it's docked, we open it and we can get all the cargo out. I've seen the Dragon in Los Angeles, and it was very impressive to see how that is all built and how it looks inside. And I really look forward to see the real thing coming to the station and have it grappled and bring it to and dock it to the station. Very nice.
Tell me about that. What work does your crew have to do before these ships arrive in order to get ready? And then what's your participation in their arrival? As I guess in contrast to a Russian Progress ship that people are most familiar with, which docks automatically, in the case of these vehicles, the crew members are very much involved.
Yes, well, don't underestimate the Progress arrivals, because there the cosmonauts are also they have their console and can and fly the Soyuz if needed. This is another concept, so it's not flying in, but it's coming up to the station, and it hangs close to the station, very stable. And then it's up to the crew to come with the robotic arm and grapple it. So it's a free flyer, and that is of course a skill. So we do this with the three of us. So one is flying the arm, the other checks the system, and the third one is having the overview and making sure that, because we have three vehicles here. We have the space station, we have the robotic arm, which you can see as a vehicle, and we have then the free flyer to be captured. And of course, it's pretty massive, so we have to be very careful that everything is stable and everything is grappled within time. And that's an interesting task. We practice this a lot. It's a skill, and we have a control board also for the vehicle. So when everything is set, we can put the vehicle in free drift, so it's hanging there, and quietly, with this, hopefully with no speed at all, and then the robotic operator can fly the arm in, grapple it, and then we have it, and then it's like a normal payload, and we can dock it to the space station.
In these cases, who are the three of you that are going to be working this?
What the planning is now, we have Dan Burbank, Don Pettit, and me. Then for Cygnus and HTV, we have a shift in because Dan is then back already, and then Joe Akabe will be in the team. So we shift that a bit, and so Dan will grapple the Dragon. Don will be M2 for the Dragon. I will be VV3, and we have all these acronyms for that. So M2, M1, M2 is also VV1, etc., etc. And we have a similar thing for when we dock it. We have also a CBM operator then for the docking mechanism. So we mix the roles for depending on the part of the task.
Mixing in commercial cargo ships for the first time. Do you get the feeling like your flight is marking an historic transition into a new era?
Yes, I think this is indeed the start of a new era where we have industry, commercial companies getting into the game, into space business, and I think this is also the whole idea of ESA, of NASA. New things should be developed by this kind of agencies because you have to invest. It's risky. You have to find out what is possible, what's not possible. Once things work, what you also see in rockets, you develop a rocket, you test it, and then commercial companies take over. And I think the same thing is now happening with the space station. The role of ESA and NASA is to look forward, to explore and go into new things, while a space station in low Earth orbit slowly becomes normal. So commercial companies can get involved and take over, while the agencies look further out and do new things.
Okay, well, if we're starting that new era now, let me get you to, speculating is bad. Dream for me for a minute. Where are we going to be in 20 or 50 years? And how is this project, the International Space Station, getting us ready to go there?
Yeah. Yeah, this is it's always an interesting question because I always say people will be on Mars in 25 years, but I realized that I said that 25 years ago already. So things go slow, but that's only in our perception. If you look 100, 200 years from now and you look back, then people don't see all the dips. You know, you see only a steady line. You see Sputnik, Gagarin, Armstrong, and then probably only Mars. Probably the space station is so normal by then, or other space station, and work in low Earth orbit. That is part of our lives, like all the satellites that we are using every day already. So I expect that say low Earth orbit becomes more and more the terrain of industry and commercial companies, tourism, things like that. That will happen, like it happened with shipping, with aviation, same thing. And then I think it would be very interesting to see what's going on later on the moon, and I'm sure that people will go to near Earth asteroids. That's a great, interesting plan, or and go to Mars. It will happen, and I guess I expect that it will be an international effort. It doesn't have to be, but it's a challenging thing. I mean, we know a lot about Mars. We have all the details. In the past, people boarded wooden ships, didn't know if they would come back or fall off the Earth halfway. They got all kinds of diseases, and half the crew didn't return. Now we know where we would land on Mars. I mean, every detail is more or less known, but it's still a challenge. Radiation-wise, it's long, and you cannot just return. But that is the challenge that agencies like ESA and NASA will take, and this will happen. People go back to the moon. The moon will be used for all kinds of reasons, for science, for say mining, things that are still science fiction now. But they will happen in the future. The world we live in is also science fiction for the people from not so long ago. All the things we do. So I expect that space exploration continues with robots, with people, and I'm very confident in that humankind will spread in our solar system and even beyond with new technologies that we can even think of today.
And the International Space Station is the next step?
International Space Station is a base for all these things. In the International Space Station, you do the research, and you do the preparation for the future steps. I like the expression from that we're standing with our toes in an ocean that's still to be discovered. We're only with our toes in the water at the moment, and there's so much to discover, and it will continue in ways that we cannot even imagine now.